We're going to be doing lesson 4 today, day 1. This is the notes we did if you are a 10th grader and you are out doing your STAR test. So, let's focus, hopefully, there we go. Transformation rules. We're transferring graphs of exponential functions. We'll do graphs of logarithms tomorrow. So, as a review, transformation rules, they apply the same way as they have in the past. So all our same rules work for exponentials. If we're adding, okay, inside, this is a horizontal change. Horizontal. We always go ahead and do the opposite with our horizontal. So if I'm doing horizontal, inside, adding, subtracting, well, normally when we add something, we think that number is going to get bigger, so we think to the right on our graph. But we always do the opposite, so this is moving to the left then. Subtracting, well, that means it's going to be to the right. Now if I look at adding and subtracting on the other side, well, this is on the outside now, so this would be a vertical effect. And these ones do what we expect them to. If I'm adding something, well, it's going to change vertical, that's going to move it up. If I'm subtracting it, that's going to move it down. So those are translations. Next, I'm going to look at those negative multiplications. I don't know why we don't like these ones, but we don't. Negative, it's not a stretch, it's not a shrink, it is a reflection. So you should feel reflection in here. Now remember, if I am trying to change my values that are x, horizontal, that means I must reflect over y. So I'm just going to draw an arrow here and say this is over the y-axis. Next, over here, if I'm trying to change my y values, that means I need to reflect over the x. So for this one, I'm going to write over x-axis. Now, normally when I think greater than 1, I would think, oh, this is going to get bigger, but opposite. So this one is a shrink here. So we have a shrink. And then when it's between 0 and 1, those decimals, fractions, things like that, it's going to be a stretch horizontally. Next, over on our vertical multiplying, if it's greater than 1 here, this will be our stretch this time, because it does what we expect it to. 0 to 1, that's our shrink. Okay, at this point, if you need more time to get these in, pause the video. Okay, next we'll be doing example 1 for this. Example 1 says, describe the transformation from f of x to g of x, then graph both, stating each function's domain, range, and asymptote. So it's a lot they want us to do. I would go ahead and say, alright, first thing, they want me to describe the transformation. I have 2 equations. I'm going to be graphing them both anyways. I'm just going to ignore g of x for now. I'm going to go ahead and just get that original function graphed and figure out what I know here, because this is what we're more familiar with. So first thing, I'm going to plot some points, so I'm going to make a table of x and f of x values. Because our base is a fraction here, this 1/2, and it's smaller than 1, I'm going to go ahead and start my x values at -2. Do -1, 0, and 1, but remember, you could pick any x values as long as you can actually plot them on your graph. When we plug negatives in, remember, our exponent rule says if I have a 1/2 to the -2, I have to take my reciprocal here. So I flip this fraction over, I end up with a 2 over 1, or just a 2. Square it then, because that was my negative, now I square it, that gets me a 4. So in this one I'll have 4. Go through, follow that same process for each of these. This one will be a 2. We no longer have negatives here, anything to the 0 power is 1. 1/2 to the first power is that 1/2 back out. So down below I should have -2 up to 4, -1, 2, 0, 1, and 1 and 1/2. Okay, so now that I have these plotted, we're going to connect these here. This will just keep growing up that way. and then this will come down and approach that asymptote that is at that x-axis. So remember, it keeps going out and it's getting closer and closer to 0 technically, but it's never actually touching it. So that's the part that I'm going to be answering next, is just that question that asks the domain, range, and asymptote, because I want to know it for both my graphs. So for f of x here, my domain, remember for our exponentials it's never going to change, this is going to be all real numbers. My range, well, it can't go below that asymptote that's at the y equals 0, so it's always going to be above it. Y is greater than 0. This is true for every exponential that has not been transformed. We'll talk about that more in just a second. Last thing is that asymptote. I said that earlier, y equals 0. So pause the video now if you need time to catch up on your notes. Okay, so now that I have that, I'm going to go and I'm going to start looking at my transformations. So if I look at my equation, I have this minus 4 here. Well, we have two choices, inside or outside. So inside our functions, with exponential, our function is actually that exponent. So if I have b to the x, well, my x is my function. So if it's inside my exponent as well, say I had an x plus 1, then that would be something that would have a horizontal effect, and we would know, oh, it's going to the left one. Vertical, it will not be in my exponent. I'll have that up there, and then the plus 1 down here. Instead, it would be going up 1 unit. So if we look here, I have that minus 4. It's outside of my function. It's not in my exponent, a vertical effect here. Okay, well, next it's subtraction, so I know it's moving down. So what I'm going to do is I'm going to say this is a vertical translation, and it's down 4. So we have two choices from here. We're going to be graphing g of x, and we could make ourselves another table, plug some points in, see what their values are. Or what I'm going to do is I'm going to say, well, what would this point be if I just brought it down 4? So if I'm here, I'm going to go down a 1, 2, 3, 4. That gives me this point here. Well, here, go down 4 more. 1, 2, 3, 4. I'm just going to do that for each of the points I already found. Down 4 gets me to 3. Down 4 gets me to that negative 3/2. So now you can see our graphs. We just took those 4 points and they're down here now. Connect your dots. They're going to go up and they're going to be kind of like consistently parallel to each other almost. So down here it's going to maintain that shape, and it's still going to have that shape where it's forced up above this line, but now it's no longer at this x-axis. It's at this line right here. Well, my asymptote was at y equals 0. That also got shifted down 4 units, so it's now at y equals negative 4. So up above here, for g of x, well, domain is not ever really going to change. It's going to be all real numbers unless it's a real-life situation. Our range here, well, it was at 0 because that's where my asymptote was before, but now I've moved it down 4. I can have the values negative 1, negative 2, negative 3, all the way up until just before negative 4. So y is greater than negative 4. Lastly, that asymptote, we already talked about it. Y equals negative 4. So we have to go through and be able to apply all of our transformations. Our translations are our most common ones that we'll work with, but we still need to be able to know how to do those stretches and shrinks. So you should try this practice and the practice on the next page. Remember to look out for where those transformations are occurring. So like in this example here, we have 1 in our exponent that will be a horizontal effect, and we have the plus 1 here that will be a vertical effect there.